Hey everyone, today we are going to move on to chapter 4 in your book talking about sensitivity analysis. Fundamentally, what is sensitivity analysis, or SA? That's just what happens when a model changes. Many of you may have been wondering up to this point, well, hey, I'm building these programs, but what if something changes? Because supplier costs change, restrictions change, values change. So what happens when those objective function coefficients change, or my constraint coefficients change? What happens if there's a change in a right-hand side value? Or what about what-if scenarios? If I want to plan for the future, I may need to plan for changing costs or prices or changes with suppliers. So what kind of things can I do to analyze these questions? Well, really, you have two options. One is you can build multiple versions of the model. Sometimes that's not a big deal. It's a simple model. You can rerun it multiple times with different values and record the result and do comparisons and analysis, which is fine. If that works for you, you can do that as well. But there's a more technical, sort of built-in way to give us some advantages called sensitivity analysis. And that is all based on reporting. So we're going to dive right in, as always, to an example. We have our Hydrolux model here. We have two products, Aquaspas and Hydroluxes. Aquaspas need one pump, 9 hours of labor, and 12 feet of tubing, and generate $350. Hydroluxes need one pump, 6 hours of labor, 16 feet tubing, and generate $300. Right? There are $300. There are 200 pumps, 1566 hours of labor, and 2880 feet of tubing. Formulate a linear program to maximize profit. So you'll see here I've done this both in the spreadsheet and mathematically. We have our math down here. We have our spreadsheet here. I've gone ahead and done this since I know you're all experts at it now. So we'll jump into Solver. And we'll say that we want to take our objective, maximize it by picking how many of these to make. We are going to go ahead and say the amount used here must be less than or equal to my amount available. That's really the only thing we have here. I have my unconstrained variables as non-negative, and I'm solving a simplex problem. So let's solve this. Okay. Now you'll see over here on the right, we've been ignoring this for quite a while. Answer, sensitivity, and limits reports. These are now something that we want to see. So I'm going to go ahead and check all those. I'm going to hit OK. And you'll see I'm going to get 3 new sheets here in my workbook. The first one is my answer report. We're going to zoom in so we can see this. You'll see this gives us some good information. This tells us basic information. Solver found a solution. All constraints and optimality conditions are satisfied. It was done with the simplex. It took this much time, 2 iterations, all this kind of thing. You'll see these are little details about the actual simplex algorithm. Your book actually covers the simplex algorithm in this chapter. You are welcome to dive into it and read it. It is wonderful to have a understanding of that, as well as at least a minor grasp on what it's doing, but I am not going to ask you questions about that. You'll see we also have some more information down here. We have the name, it connected some things, Profit Aquaspas. So you'll see it went Profit Aquaspas. It used the row and the column to come up with the name. So that's something you can keep in mind when you're generating these. Original value of nothing, final value 66,100. Great. Variable cells, Aquaspas and Hydroluxes, same kind of thing. It tells us these are both continuous values. And then we have our constraints down here. This is actually really an important part. They tell us the cell value, they give us the formula, and they actually give us these items here, which are really important, telling us whether they're binding or not binding and what the value of the slack is. So you will remember that I talked about binding versus non-binding variables in a previous video. Binding just means that the value that's on the left-hand side and the right-hand side of the inequality are the same. So you'll see here we are bound by these 2 constraints. Oops. This 200, this 200, this 1556, 1556, they're equal, so we are bound by that. Where we have some room to play in our tubing, right? We have some slack. So when you think of the answer report, and just to put this in context, we could call these variables S1, S2, and S3. These would be our slack variables. The way that this works out when you look at the problem, we'll go ahead and do the math very quickly here for you. If I take my original formulation, the way that we deal with slack variables is we have this same problem here. We change our inequalities to equalities, and then we add three variables. We'd say plus S1. We would say plus S2. And we would say plus S3. These are the slack variables. You saw I named those in the answer report. And here I'm adding them into my model. We're just going to do a quick bit of formatting so this is much easier for you all to read. And you'll see this is what the simplex algorithm actually does. It adds these slack variables, S1, S2, and S3, into every inequality in order to make an equality. Now, if these were greater than or equal to constraints, the sign on these would change to negative, just because you're going the other way. But this gives us our slack variable. Okay? So this is what the answer is showing us. It's how much slack that we have available in our constraints. So you can see what I have here is that the tubing, that amount doesn't really matter because I have enough of it. I have 168 extra units or extra feet of that left, and it is a non-binding constraint. Okay, so this is report number 1, our answer report. We want to take a look at that, see what we do, deal with our slack variables down here. Okay? We'll go ahead and split this off so it's easy to see that one is with slack and one is without slack. The next report that we have is quite a bit more complex, and it has some different information, even though it looks smaller. This is our sensitivity report. Okay, so this tells us a lot of things. The first thing is it gives us our variable cells and then our constraints, and it gives us some good information. So if we want to look at our variable cells first, you'll see that we have aqua spas and hydroluxes. That's correct. We have our final value. Now we have a lot of different fields here. We have reduced cost of 0. We have the objective coefficient, 350 and 300. You can see that comes from right here, right? That's the objective function coefficient directly related to this variable, right? So I multiply 122 with 350, 78 with 300, add those up, and I get my profit. I have an allowable increase, and I also have an allowable decrease, okay? So this is the allowable increase or decrease before my solution changes, right? So basically what this means is if I go in here, I can increase my objective coefficient for aqua spas by $100 or decrease it by $50 before anything changes in my final solution, right? Before anything changes in my final solution, okay? Now the profit value, my actual objective function, that will change, right? So you can imagine if I look at my sensitivity report here, I can increase this 350 by up to 100, or I can decrease it by 50. You can quickly see that, well, hey, I can do this, right? I'll increase it to 400. That's going to change my profit, but it will not change my variable cells, right? It won't change the value chosen there, because everything else has stayed the same. Okay, so it will change my profit, it won't change anything else. I have the same thing here listed for hydroluxes, right? I can increase this by $50, or I can decrease it by $66.67, and I have the same idea, right? So this is the allowable increase or decrease, right, which is really good. Now, if either of these allowable increases or decreases are 0, this may indicate that your problem has multiple optimal solutions, so more than one solution. All right. As we move on, that explains most of the items here. The one item I have not explained is reduced cost. You'll see reduced cost for each variable is equal to the per unit amount the product contributes to profits minus the per unit value of the resources it consumes. So fundamentally, reduced cost is my profit minus my costs. Okay? If this is 0 or positive, you're going to produce, you're going to have a value. If this value is negative, it means that I'm basically not making any money. It would not contribute to my objective function, so I should not be too worried about that variable. We also have some information down here, which is very, very handy and very important. We have information about my constraints, my pumps used, my labor used, and my tubing used. You'll see I have a final value here, 215.66 and 27.66. You'll see that. I have my right-hand side, which is good. Now I also have my allowable increase and allowable decrease for my right-hand side. Now one thing I do want to stop and mention at this point, all of these changes, all of this evaluation that we're doing, you can only change one thing for all of this to hold. If you change more than one thing at a time, this does not apply. So remember, you can only check on one change at a time. Okay? So we have a lot of different things going on down here. Okay? We have my shadow prices, right? And we also have allowable increases and decreases. Okay? So let's go through these one at one. Allowable increase and allowable decrease tells you how much that the constraint on that right-hand side could change, right? Before the optimal solution would change. That's the optimal value up here that we've chosen. So we have allowable increase of 7, allowable decrease of 26, 234, 126. Now you will note that the tubing amount used here, we can increase it as much as we want, and it has 0 impact. The allowable increase is 1e to the 30. That's the same as infinity. You also see this as 1e to the negative 1e to the 30, which is minus infinity. That means we can increase it as much as we want. Why? Well, if you look in our model, we are not using all of our tubing. So of course we can increase this value as much as we want. Nothing will change because it's a non-binding constraint. But I can increase my pumps and my labor and get some benefit up to a certain amount, right? So allowable increase 7, allowable increase 234. This allows me to, right, increase my profits and things like that, which goes to shadow prices, right? My shadow price is the amount by which my objective function would increase per unit increase in right-hand side. So for instance, I'm allowed to increase this right-hand side by 7. So I might ask you, well, how would my objective function change if I got one more pump? Well, one more pump, is it within my allowable increase or decrease range? Yes. My shadow price is 200, so it should increase my profits by $200. If I said I'm going to decrease by 2 pumps, I'd say, is that in my allowable increase decrease? Yes. That will decrease by 2 pumps. That should lower my value by $200. Another way to look at this is to say, this is the value of one additional unit to me. So for a pump, I'd be willing to pay $200. For another hour of labor, I'd be willing to pay $16.67. And this would give me my hourly labor cost, what it's actually worth to me in this scenario. So you can see I have a lot of useful information here that would actually help me tremendously. So I can give you an example of this, right? So let's say this. Would you be willing to sell a new model of hot tub that uses 1 pump, 8 hours of labor, and 13 feet of tubing for $320? Well, how do I figure this out? Well, what I do here is I say I can take 1 pump, I can multiply that by $200. Right? Because it takes 1 pump. I can take 8 hours of labor that it requires, and I can multiply that by 16.66, right, which is my shadow price up here. And I can say, well, 13 feet of tubing, what's the value to me? That's 0. If you do the math here, right, and maybe we'll do this a little different way. No, we'll leave it like this. If you do the math here, this works out to 333.28. Okay, so I'm going to end up with $333.28. Now the question I have to ask myself is 333.28. How does that compare to my $320? Well, it's greater than or equal to that. So the answer should be no. I'd lose money. All right, so I don't want to produce this because it's costing me more than I could sell it for. If I could sell it for at least $333.29, then I would be in really, really good shape. Okay? So this is fundamentally how shadow prices and right-hand side values change. Okay? Just so you know, changing the right-hand side value will adjust the objective as expected, but it may also change the optimal values, right? So it may switch some things around. So all this in here, the shadow price and all this tells you how your objective function will change, but it does not tell you how your mix of variable values will change. Okay? So we have a lot of things here, right? You've noticed, by the way, this, just to be a refresher, a constraint that is non-binding has a shadow price of 0 because I have extra. I don't need any more. The shadow price is the per unit value of every resource, right? So fundamentally, I am willing to pay for this $200 or $16.66 per unit. That's also the amount it will adjust my objective function as long as I change my right-hand side within this allowable increase or decrease. In addition, I can look at what happens when I change my objective coefficient of value within this allowable increase and decrease and how that impacts my profit and costs. Now, one thing that you really do have to look out for in these models is something called degeneracy. Degeneracy occurs when the allowable increase or decrease of a right-hand side value is 0. So if I look in here and I have any zeros, if I look in here, any of these, that would be degenerate if the allowable increase or decrease of the right-hand side is 0. Okay? Lots of stuff in here will start to happen and get sort of wonky if the problem is degenerate. Fundamentally, you can't trust anything that this model now tells you. You can't find alternate optimal solutions, reduced costs are meaningless, objective coefficients still hold, but they may have to change beyond those limits to impact the optimal solution. Shadow prices may not be unique. So always, always, always check this first. Okay? Always, always, always check for degeneracy first. The final thing we have is our limits report. The limits report just tells you the lower limit and the upper limit and how it impacts your objective value. So I now have 3 reports. All of these are related to a single model. They give me all the details and everything I need to know in terms of analyses and working these out. Now, the one thing I do want to show you here, I want to walk through this very quickly. We had degeneracy. Some key points that I do want to leave you with. Shadow prices equate the marginal value of resources consumed with marginal benefits of goods produced. Resources in excess supply always have a shadow price of 0. That's just common sense. The reduced cost of a product is the difference between marginal profit and marginal value of resources consumed. Makes sense? And products whose marginal profits are less than the marginal value of the goods required for the production will not be produced. Basically, if I have a product, this is exactly what I showed you. If I can't make enough money for it, if it doesn't contribute to my objective function, I will not make it. Okay? These are the fundamental key points. Now, I have covered an awful lot very quickly in this lecture. I've gone from building a model to solving it to looking at an answer report, which shows me all the values of everything in my model as well as whether they are binding or not binding. I have looked at the sensitivity report, which shows me impacts if I increase or decrease my objective coefficients. I've looked at the reduced costs. I've also looked at my shadow prices, which are the per unit value that I'm willing to pay for most of these items over here. I've looked at allowable increases and decreases. I've also talked about degeneracy. These are all things that are very important to your models and allow you to do a full analysis and workup to see how your model will change if things change for you. Do remember, this method is often quicker than simply re-solving your problem for any problems of a significant size. So, you should be good to go.